will be about differential equations with related rates. So we have a cylindrical tank and the water is leaking from the tank at the given rate. So we can use the given information to see how dV dt changes with height, and it's a negative rate of change, less and less water. If we substitute the given condition, we can calculate the value of K. Since it is a cylinder, we can find volume as pi r squared h and the derivative dV dh. And now we need to use related rates to finally obtain the equation dH dt. So we are to find the height of the water after 30 minutes, but the original rate of change is in hours, which means after 0.5 an hour. We're ready to go to the calculator screen and choose menu, calculus, and if we need to go to differential equation solver, we can enter the equation. So we know the rate of change h, dashed we get from here, is equal, and we can use the fraction screen, and we know it's negative 8 and square root h divided by 15 pi. Now if I use this arrow, I go back up, and I need to use the initial conditions. I need to put a space and then just type end and another space, and now I can put h in 0 is equal to 2.25. That's not enough yet. I need to tell the calculator what my independent variable is. I go comma t, and what my dependent variable is, comma h. And now I enter, and this is the relationship between h and t. It's square root h, which is not what we want, but if I press square, I have the relationship for h. To be able to use it, I will take the calculator. I want it to remember that this is h in t. So if I go to the left and I say I want it to be h in t, but instead of using equal, we delete that and we say a sign. So I'm telling the calculator, remember, that's my h in t, and I press enter. And we need to find h after 0.5 of an hour. So this is the answer in meters. The question asks to the nearest centimeter, so we go times 100, and that's 212 centimeters. Question 2 is asking find the length of time to the nearest minute before the tank is empty. What we need to do, we need to change dH dt to dt dH, and then we'll be using definite integral to find the time for which h dropped from 2.25 to 0. How do we do it on the calculator? We go to the template, and we use a definite integral. So the original height was 225. I can use tab to get to the upper limit, and the upper limit is 0. If I use tab, now I can enter the equation, again using control menu. I have this time minus 15 pi over 8 square root h, and my variable is h. It comes in bold because it was defined, but it will not have a big effect here. So this is time in seconds, so we need to go times 60 to get in hours to get the time in minutes. So that's 1060 minutes. Answers our second question.